All right, hello again, everybody. Here we are with our first problem for our Python in 5 Problems video series. And this one is dealing with a ball that's been thrown up in the air. And we're told that the height of the ball in meters, t seconds after it is thrown, is given by the equation h equals negative 4.9t squared plus 20t plus 2. And we're supposed to investigate how the ball's height changes over time. So let's think about how we could do that, and then about how coding can help us out. So one of the ways we could start to investigate how this ball's height is changing over time is to start finding some height values based on time values. And I don't know about you, but the idea of sitting there with a calculator and repeatedly typing in this calculation to come up with different height values, to maybe record it in a table of values, doesn't sound like fun to me. I think a much more valuable approach would be to see if we can kind of harness the power of Python to do these calculations quickly and easily for us. So that's what we're going to do. Now, before we actually start doing that in Python, I'm going to use something that I'm calling pseudocode here. And what that is kind of like a list in blocks of the steps that we're going to take when we actually get to Python. And just a little bit of a warning here, this isn't actual real pseudocode. Real pseudocode, I believe, looks more like actual code. It's just not specific to a language. But this will give us a clear idea of our path, and it's also kind of useful because this is likely how students will see coding questions on EQAO and so on, where the language will not be specific, because there are, once again, are several languages out there that are likely being used. So how are we going to do this? Well, the first thing that we're going to do is we're going to set a time value, right? If you were trying to find a height value for a certain time, the first thing you would do is you would choose a time. So we can pick some time value. It can be whatever you want, 3, 4 seconds, 0 seconds. It really doesn't matter. And then we're going to tell Python what that time value is and ask it to calculate the height. And as you can see here, we just have the height equation. It's negative 4.9 times the time squared plus 20 times the time plus 2. So Python will do that calculation for us, and then we'll ask Python to show us the result. And in Python, that command is called print. We'll ask it to print the height. So that's our path, just a 3-step path. So let's see how we could actually do this in Python, and then we'll kind of talk about why it's handy to have this set up in Python. So here's the program is Python online compiler that I talked about in the first video. And if I go to full screen, it looks like this. I've zoomed in a bit so you can see it more clearly, but I'm going to just minimize it a little bit here, shrink it down so we can still see our pseudocode on the right. So the first thing I would recommend you do here is just get rid of all of this text that's here. So highlight it, hit delete, and it's gone. Okay, and what we're going to do is we're going to type our instructions, our code in this window here, and when we run it using the run button, we'll see the results in this shell. Okay, so what are we going to do? Well, the first thing that I'm going to do is I'm going to make what is called a comment. And a comment is really just a note about what I'm doing. It won't be used for any type of calculation or anything like that. It's just a note so I can see, if I need to in the future, what my intentions were at this part of the code, what I was thinking, what I was doing, but perhaps even more importantly so, if somebody else is reading this code, they know what it is that I had in mind. And anytime we want to make a comment in Python, we just start with the little number sign, that hashtag sign there. And Python will automatically recognize that I'm writing a comment, and this is nothing more than a little note. So I'm going to say I'm going to set the value for time, and that's exactly what we said we were going to do. We're going to set a time value. Now let's actually do that. Now we could call our time variable anything we want, really. We can call it time. Okay, but in math we often shorten that up to just a single letter. So I'm going to represent time with t. And what I'm doing here is I'm telling Python I want a variable called t. And then I'm going to say I want its value, so equals, to be 0. I'll just choose 0 right now. You can choose something else if you want. Then I'll hit enter, and I'm on to my next line of code. So think about what we've done. I've written a comment here saying what I'm going to do, and then I've told Python I want a variable called t, which obviously represents time here, and its value is going to be 0 right now. I'm going to skip a line. You can do this in Python. You can skip lines anytime you want. It doesn't matter. It kind of helps keep things organized and kind of easy to see what's going on if you leave a bit of space there. Make another comment here, and I'm going to move on to our second step, which is to calculate the height. So calculate the height. All right, so to do that, I'll introduce another variable called h. Okay, I'll hit h equals, so Python knows that I'm now defining a variable called h. Now, what do I want it to be? Well, I want it to be based on our time, and we know we have this equation here. So I'm going to put this equation in, and pretty much going to type it, like it was originally presented. So negative 4.9 times. Now, I can't write times squared here because remember I told Python that the time variable is being represented by the single letter t. So I'm going to write times t. Now, how do we do squared? Well, I guess one of the easiest solutions to this issue would be we could write times t times t. That would be the same as squaring t. But there's another little trick, well, not really a trick, some other syntax you can use for exponents in Python, and that is to use the double star here and put a 2. So that will be interpreted as t squared, okay? And then we'll get the rest of our equation there, so plus 20 t plus 2. Now, if you're wondering, did I purposely make an error there? I did. Perhaps you see what it is, and there's a reason I made this error. We'll see what happens when we run the program, but in the meantime, let's just finish up here by saying we are now going to take that calculated height and print it. So print height. And if we want to display something in Python, display a result, we use a command called print. So we'll just say print. When you type that in, notice it turns blue. Python recognizes here that we are using the print command. And then in brackets, we have to state what it is we want to print. Now, if I just put h, it's going to print that height value, which is great. But I can also put some text in there. Perhaps I want to say, instead of just printing the value, maybe I want to say the height is, and then print the value. And I can do that. If I want to just print some text, I put it in quotations. So I hit the quotation key on my keyboard, using shift, of course, and I type in what I want to say. So we can say the height is, maybe we'll put a little colon, and then on the next line, I'll print the actual height value, which is h, and see what happens. Now I'm going to run this, so I'll go full screen here, and I'm going to hit the run button and see what happens. Oh, there's a syntax error. Now what is the problem? What went wrong? Well, it was related to the fact that I did not use a multiplication sign right here, okay? Notice that when I did negative 4.9 times t squared, I used the little star for multiplication. I need to do that here as well. So for 20t, I actually have to input 20 times t like that. And now when we run it, we get the height. So this is kind of handy because what we could do now is we can go back and we can start changing the height. We could say what is for 3 seconds. We can go back here and say what is it for 2 seconds. And we got this handy calculator that quickly gives us height values based on time values. And of course we could then input these values into a table of values and see what happens. You could also use decimals, 0.5 seconds. No problem. Okay, now watch what happens if I use 5 seconds. Oh, that's a little bit weird, isn't it? Bit of a complicated result here. What's with all these zeros and this 1,4 at the end? Well, remember in the first video we talked about the different data types that that Python uses, and what's happening here is 5 is an integer, okay? But when I input it into this equation here, it's returning a floating point number, a float, okay? And how do I know that? Well, one of the obvious reasons is because we're using a decimal number in that equation there, so it's going to return a float or a floating point number automatically because of that. Now, I don't necessarily want to see all this stuff at the end here, this this rounding error, this approximation, whatever you want to call it. So what I'm going to do in the next step here is I'm going to round that final height value. So what is that going to look like if I want to round it so it doesn't give me that that huge string of digits there? Well, I need to introduce another step. Once we've calculated the height, I'm going to introduce a step where I now round the height. Okay, so we set the time value, we get Python to calculate the height, then we get Python to round that height value. And of course, then we don't want to print the height value, we want to print our newly rounded height value. So what is this going to look like in Python? Well, we just have to add that extra step in. So we'll start again by setting a value for time. Okay, we can just leave that at 5 for now. I'll just modify this code here. I'll alter it as stated in the expectations. We are going to still calculate the height, but now I'm going to throw an extra line in here where I'm going to, and I'll make a comment for it, round the height value. Okay, and how do we do that in Python? We use a command that's actually called round. And I think I'll give the rounded value a new name. I'll assign a variable, and we'll call that h underscore rounded, which is our rounded height value. Notice I used an underscore right here. Okay, when you're naming variables, you don't want to have any spaces. So if you want to kind of see the space, just use an underscore. So how are we going to calculate this rounded value? Well, we're going to use the round command. So you just type round, and then in brackets, we have to state what it is that we would like to round. So we want to round the height value, which is h. How many decimal places? Let's say 2. So if I hit comma 2, it is going to round that height value to 2 decimal places. And now I want to go and print the rounded height. Okay, but let's do something a little bit different here. I'm going to get rid of this line and just show you something that's kind of cool here. This here, this statement, the height is, that's a string. It's enclosed in quotation marks there. If I did something like this and said the height is, and then I wrote, say, h rounded, because we want to print the rounded value, we're going to have a problem because h rounded is a floating point number. It's different type of data. So how can I do this so that I have text, printing text or a string, and then printing a variable on the same line? Well, it's actually really easy to do. All I need to do is put a comma after that first string. Okay, so the height is in quotation marks. Then I put a comma. Now I can just put h rounded, that's my variable. And just for fun, let's put in some units. So I'll put another comma, switch back to a string, and we'll say meters. All right. And that should do it all on one line. So let's take a look. If I now hit run, there we go. Notice that, first of all, we have the height is negative 20.5 meters on a single line. And also notice that our value is no longer that weird string of digits. It's been rounded. Now, 1 decimal place here because it was just a bunch of zeros after, so Python took the liberty to just round it to negative 20.5 instead of showing 50. But we all know that that is fine. What else to mention? Well, obviously you wouldn't really be interested in this particular height because the ball at that point would have hit the ground or whatever it is that we're talking about. But we've made our point here. We've rounded and we've now got a way of printing strings and variables on the same line. But you might not be satisfied here at this point because we haven't really made our lives all that easier. Let's really harness some programming power here and get Python to do several calculations all at once very quickly. And to do that, we are going to use a new concept here, and that is the concept of a loop. Okay, so what is a loop in programming? Really, it's just instructions for Python to do something over and over and over again, repeatedly. And in this case, it's going to be to repeatedly calculate height values, okay, based on time values. So how can we do that? Well, first of all, we need to start a loop, okay? And we have to kind of tell Python how many times to do that loop. So we'll say, let's use 10 consecutive integers for time, starting at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Start at 0. Go up 10 consecutive integers, and each time we do that, we'll calculate the height. So we'll calculate the height for 0 seconds, then we'll calculate the height for 1 second, then 2 seconds, and so on. So we're going to start that loop, and each time we run the loop, we're going to make this calculation. Now notice I've indented this box a little bit. That's very similar to what you're going to see when we go over to Python. And pretty much what happens here in the pseudocode is every time I start a loop, the stuff that's happening in the loop will be indented. So I'm going to calculate the height each time, and then we're going to print the time and the height. Let's print the time and the height this time, not just the height result. And we're going to keep doing that over and over again until we've done 10 consecutive integers starting at 0, and then we'll end the loop. Okay, and that's the idea. We'll start a loop. We'll input 0, calculate the height, print the time and the height. Then we'll do it again. This time we're going to do it for 1 second. So we input 1, calculate the height, print the time and the height, and keep doing this until we've done 10 consecutive integers, and then we'll stop the loop. So let's head over to Python now and talk about how we can actually input this. So the first thing I'm going to do here is I'm going to clear all of the code that I have in there, just highlight it and hit delete. And I'll make a comment here. I'm going to say calculate and print several heights. Okay, so now remember we're going to do a loop. We're going to start a loop. And we're going to say do this starting at 0 and for 10 consecutive integers after that. This is called a for loop in Python. And we're going to pretty much say for time values, so for t, in a certain range. And this is actually a command called range. Now, what range are we talking about? We're talking about starting at 0 and going up 10 consecutive integers from there. So that is input as range 10. Okay, so we're telling Python we want a loop. Okay, that's what the for is indicating here. And that loop is going to be based on time values in this range. And this range is 0 to 9. Beware of that, right? Even though we said 10 here, it's 10 consecutive integers starting at 0. So it's 0 through 9. And what's very important is that we now put a colon here, because that really tells Python we want a loop. And watch what happens when I hit enter. There's an automatic indentation. And everything that's indented now is going to be included in this loop. So what was it that we wanted to do? Well, we wanted to calculate a bunch of height values. So we'll say h equals, and the height values will be calculated by our equation. So negative 4.9 times t squared plus 20 times t plus 2. And you know, while we're at it, why don't we round this result? We can actually do that here if we just say round, using our round command, get some brackets here and specify we're going to round to, let's just say maybe, I don't know, 1 decimal place here. Okay. Now that will do the calculation repeatedly, but it's not going to show us anything right now. We also have to tell Python, once you've done that calculation in that round of the loop, go ahead and print the result for us. And this time we will print both the time value as well as the height value. So print t and h. Now I'm about to run this, but just note that when we kind of set things up here, we did define a couple of variables. We said for t in this range, so it's going to use a bunch of t values for t here. And we've also defined our height variable, which is h. So let's go full screen here, hit run and see what happens. There it is. Look at that. Starting at 0 for 10 consecutive integers for time, it's calculating the height for each one. Pretty quick and pretty valuable. Now, when we did this workshop live, some great questions came up. One question that came up was saying something like, well, what if we only want to do from 3 to 6, for example? You can do that actually very easily. You can just modify this range and say, I'd like to go from 3 to 6. Now, here's the trick you got to remember. You have to put a 7 here. Just like when we put a 10 for range 10, it went from 0 to 9. If we want to go from 3 to 6, you have to type in 3 to 7 because it'll go up to, but not including that 7 there. All right, so now if we run this program, we'll see that it only does it from 3 to 6. And another kind of thing that's kind of neat is you can specify the increment by which we go up for that time. So for example, let's say I go from, I don't know, 1 to 20, so I'll say 21. If I only want to go up by 2s, I now hit comma 2, and we'll go up by increments of 2 for the time. So 1 to 20, going up by increments of 2, and you can see it has done that. It started at 1 and it's gone up by 2s. Now as a result, we've ended at 19 here. But you can do that. Now, unfortunately, if I type in 0.5, hoping that I could go up by 0.5 here, it will not work. And the reason is because in this range command here, we cannot use a floating point number here. We have to use an integer. But in the final example of this video, I'll show you how you can get around that problem. So let's take a look at this final example, which I think is the coolest one, because if we go back and take a look at what we did at first, I think we did range 10. Yeah, there's a lot of values here that we're not interested in, specifically these ones here, which are negative values clearly after the ball has hit the ground or whatever, so we're probably not interested in them depending on the problem. And we also might want to go up by a smaller increment instead of ones here. And the reason for that, perhaps you're looking at where the ball reaches its maximum height. It would be really nice to have a better idea of what's going on kind of a smaller increment here. So let's talk about how we can do that. So we're really interested in a couple things. We really only care about time values that are greater than 0 and height values that are greater than 0, right? We don't want to use negative time values. It doesn't really mean much in the context of this problem. And height values, we're really probably only interested in when the ball is in the air, so that would be positive height values. So here what we're going to do is we're going to start a loop, and we're going to tell this loop to just keep repeating as long as these two conditions are met. As long as the time is greater than or equal to 0, and as long as the height is greater than or equal to 0, okay? But think about this for a second. In order to even start this loop, I have to have a value for time and for height, because the loop is going to look for that right away, right? We said repeat as long as time is greater than or equal to 0 and height is greater than or equal to 0. Well, if there's no value for those at that point, how's Python going to know if these conditions are being met? So I have to add in an extra step here. I have to start by kind of setting some initial values, and we'll just make it easy. We'll set the time at 0 to begin with. It's probably what we're interested in. And we'll just set the height at 0 as well. The height will be updated very soon once that loop starts. Now, this is not good enough either, because think about what will happen here. We set some initial values, say 0 for time and 0 for height, and we hit run. So Python looks for, are these conditions being met? Well, sure they are. We said time is 0 and height is 0, so that's happening. It then does this calculation. It takes the time that we specified, 0, and it updates our height variable based on that. Okay, so it's going to calculate a new height variable based on that time. It's going to redefine height as that having that value, and it's going to print the results. And then it's going to go back, and we're going to check. Are these conditions being met? Well, probably, right? Because the time was 0. We didn't change that, so it's still 0. The height would have been updated likely to a positive value because if you sub 0 in here, yeah, it's going to work out to 2. So that condition is being met as well. And it's going to now go again. It's going to input that time of 0. It's going to update the height. It's going to be the same value, right? Because we're using 0 again. It's going to work out to 2. It's going to print those. It's going to go back. It's going to check the conditions. Yep, they're being met. We're going to sub in 0 again. It's going to give us 2. So this is just going to keep going and going and going. And it's going to keep printing out a time of 0 and a height of 2. And the reason is we're not making any changes to our time for each cycle of this loop. So we have to add in one more step here, a very important step, where we increase our time value. And the cool thing is you can increase it by whatever you want. So say we only want to increase it by half a second. We can increase the time value by 0.5. Now when we go to repeat the loop, we're using a slightly higher time value, calculate the new height value, print them, increase the time value again, and go repeat the loop. And this will keep happening until one of two things occurs. Until either the time goes negative, which it won't, because we're constantly increasing the time here, or the height goes negative, which, as we saw, will eventually happen. And that's when Python will stop looping and end the loop. So we should only get values that are kind of meaningful to us for the most part, and we should be able to specify an increment that allows us to see a fair bit of detail. So I don't know about you, but I'm excited. Let's do this example here, and then we'll finish off this video. I am going to clear, once again, all of this, and we'll start with a comment. And by the way, a question came up in the workshop. Is it necessary to write these comments? No, it's not, but it's a good idea because it does kind of communicate what's going on. Other question that came up was, do I need that space there? No, it doesn't matter. As soon as you write hashtag here, Python knows that you mean a comment, so you can do whatever you want after that. If you take all the comments out, the program will still run exactly the same. So let's set some initial values. We said we're going to use a t value of 0 and an h value of 0. So we've defined t and h here, and we've specified their initial values. And now we are going to calculate and print several heights. So calculate and print, and print several heights. Okay, so how do we do that? Well, before we used a for loop, but now we're going to use a different type of loop called a while loop. And we're pretty much going to say, while these conditions are met, keep doing this loop. That's why it's called a while loop. So we'll say while, and you can type it in a really intuitive way. We can say while t is greater than 0. Actually, better yet, why don't we say t is greater than or equal to 0? Okay, just like you would say it. And this is great, you can just type and, h is greater than or equal to 0. We are going to do a loop, and don't forget you need the colon there. That's how Python really knows that you're going to do a loop, and how you're going to get this automatic indentation. Which, by the way, if you ever need to indent, you can use the tab key on your keyboard to do that. So what are we going to do? Again, we're going to calculate the height here. So h is negative 4.9 times t squared plus 20t plus 2. And once we've calculated that, we're going to print it. So let's print. And, I could just write print the time value, like I could say print t here, but instead, why don't we write round t to 1 decimal place? Only because we know that if we're using floating point numbers, which we might be using here for time, we don't want to get those kind of weird displays with all the digits after the decimal. So we'll just round it to 1 decimal place, and then we can do the same for the height. So why don't we say round height to, let's just go with 2 decimal places here. And while we're at it, something that I like to do is just to create a little bit of a space between the time and the height in our result. Let's put in a string here, and we'll just put 3 dashes, and that'll give us a little bit of a space between the two values. Now, there's something that's really important here, and that is before the next round of the loop, I want to take my time value and redefine it. I want to increase it. And I can do that by saying, take the time that we currently have and increase it by some number. So let's just say 0.1. Okay. So what happens here? Now, don't let this freak you out. This is not, the type of equation we'd solve, because clearly this has no solutions. What it's saying is redefine time. That sounds deep. Redefine our time variable's value. Reassign the value to it. And how do we do that? How do we get that new time value? We take the current time value and increase it by 0.1. So that is what's happening there. And let's see what happens. Here we go. Clear that out and run this program. Look at that. Starting at a time of 0, we're going up by increments of 0.1 seconds, and each time the height is getting calculated and displayed, and that keeps happening all up to the point where we got our first negative height, and then the loop stopped. And as you can see, this would be super handy if you're trying to find the, say, the maximum height of the ball. You can just look at these values and say, yep, it looks like it's right about there at 2.0 seconds. And of course, you could do like a finer increment here if you wanted as well, 0.01 or something like that, and it would be it would give you even more detail there. So that's it. Now, we've covered a lot in this video. It's been quite a long video. We're approaching a half an hour here, but the following videos will be shorter because there's not as much new stuff to introduce. I think we'll see what happens. But so there's the first problem. Definitely, I think too much for one lesson in the classroom, but you can now take those ideas and play around with them and introduce them as desired to your students. I hope you enjoyed that, and we'll see you in the next video.